All right, so a parallelogram is a four-sided object where both sets of opposite sides are parallel. So to be a parallelogram, this is parallel to this, and this is parallel to this. Okay? So if we have a parallelogram, one of the things that we're told, one of our theorems that we have, is that the opposite sides are congruent. So if this is 4, how long is xw? 4. And if xy is 6, how long is wz? 6. Okay? Opposite sides of all parallelograms are congruent. Okay? So if opposite sides are congruent, how do we figure out what x is? What would you do? Set 4x equal to 5x minus 3. How do we solve this, Riker? What would you do to both sides? Subtract what? 5x. So negative x equals negative 3. So x equals a positive 3. So this is 12. And this is 12 because 5 times 3 is 15 minus 3 is 12. Okay? If we stick a 3 up here, 21 minus 3 is 18. Stick a 3 in here. 2 times 3 is 6 plus 12 is 18. Okay? And there we go. Now, if we have parallel lines and a transversal, angles 1 and 2 are not the same. Angle 1 and 2 are same side interior angles. Back in chapter 2, we learned that same side interior angles are supplementary. They add up to 180. Okay? So in a parallelogram, consecutive angles are supplementary. So 1 and 2 will add up to 180. If we have a 3 here, 2 and 3 will add up to 180. Okay? Consecutive angles are supplementary. So if A is 66, what will B be? Well, you need a calculator. 180 minus 66 is 114. Well, how big would angle D be then? 114, because consecutive angles are supplementary. So it's consecutive that way and consecutive that way. So those are both 114. So what then is angle C going to be? So now all of a sudden, what did we discover? What do we discover about opposite angles? They're equal. So consecutive angles are supplementary. These add up to 180. Opposite angles are equal to each other. Okay? So this is what this theorem says, that opposite angles are congruent. Okay, so looking at this diagram, okay, it says angle 2 is twice the measure of angle 1. Okay, what's the measures of 1, 2, and 3? So if angle 2 is twice the measure of angle 1, let's make angle 1 x. So if angle 2 is twice that, what's angle 2? Okay, so what do we know about x and 2x, these two angles? If it's a parallelogram, they should add up to 180. So x plus 2x equals 180. So 3x equals 180. So if we divide by 3, x equals 60. So angle 1 is 60. What's angle 2? 120. What's angle 3? 120. Okay, there we go. The diagonals of a parallelogram bisect each other. What that means is whatever this is, this is. And whatever this is, this is. But they don't have to be equal, but they have to bisect each other. They have to cut each other in half, cut each other into equal parts. That's a proof explaining why the diagonals bisect each other. Because if you have a parallelogram, then you have parallel lines here and here, which makes these alternate interior angles and these alternate interior angles. And these are congruent because opposite sides of parallelogram are congruent, which makes these triangles congruent to each other. Okay, which then by CPCTC, this is congruent to this, and this is congruent to this, and thus we are bisected. Okay, all right. If AE is 4, what's EC? 4. And if BE is 2, what's ED? 2. So how long is AC total? 8. And BD total is 4. Okay. This person has a stamper. They're going to stamp this pattern on here. Okay. Those are ugly patterns. But they're going to stamp that on. How many times can they fit it if this is 60 long? Well, we know XD is 4. And BX would then be 4. And what does it say about AX here? It's 1.5 times BX. What's 1.5 times 4? 6. It is 6. So how long is AC? AC is 12. So since AC is 12 and this whole thing is 60, how many of these shapes will fit in there? 5. You can stamp 5 shapes on there. Okay. So the summary. Okay. In a parallelogram, opposite sides are congruent. Consecutive angles are supplementary. They'll add up to 180. Opposite angles are congruent. Okay? Diagonals bisect each other. Now there's one more thing we have to do. Okay? Here's a parallelogram. Okay? A, B, C, D. How long is AD in this parallelogram? 4. How long is AB in the parallelogram? Well, that's a little bit more of a mystery. Okay? Because you go over 1 and up 3. You make a right triangle. And how do we figure out how long the hypotenuse of a right triangle is if we know that we went over 1 and up 3? Well, we have to use the Pythagorean theorem or the distance formula. Okay? Either way. So, they're basically the same thing. If this is 0, 0, and this is 1, 3, the distance formula works out pretty well because we have 0, 0 here. So if we take x2, if this is x2, y2, and this is x1, y1, if we take x2 minus x1, you get 1 minus 0, and you square it. y2 minus y1, you get 3 minus 0, and you square it. So 1 squared plus 3 squared is 1 plus 9, or the square root of 10. So AB is the square root of 10 long. So on problem number 2, as Oliver has already discovered, because he's already doing his homework, you have to do the distance formula. So it's a little bit harder, problem number 2. So that's how you'd go about it. Okay? But besides that, you should be able to handle this assignment. I think there's like 11 problems. So let's get to work on those. It is already out there for you, so you can get started.